Today we're going to be working questions 17 through 20. We're going to be learning the Cavaliere's principle. So here, let's take a look. Well, first of all, let me talk about what's a Cavalieri principle, because I see in our homework, we're going to be using it, right? It says right there, the two triangles are drawn to scale. With Cavalier's principle in mind, find the area of the triangle on the right. Okay, so Cavalier's principle, it's a rule that states that as long as two figures look alike, so I can see there's two triangles that look alike. If they have the same base, the same height, they can be tilted. They can be moved around a little. They can be stacked. They can be stacked. One of them can be stacked in the same, like it's straight, like it's well stacked. The other one could be like a little sideways. Sideways, it could be a little crooked. As long as they have the base and they're stacked to the same height. Keep in mind, I said stacked. I didn't say it's stacked the same way. It could be straight. It could be a little slanted. As long as it is the same height, the volume of one shape, it is the volume of the other. The area of one shape is also the area of the other. So looking at here, the two triangles are drawn to scale. With Cavalier's principle in mind, find the area of the triangle on the right. It seems like the base at the bottom is the same thing, right? If I count the squares on my triangle on the left, there's 1, 2, 3, 4, 5 squares. The triangle on the right, it has 1, 2, 3, 4, 5 squares. Now the height is from here to here, which is the same on the other triangle, right? So they have the same base, they have the same height. One of them straight, the other one's slanted. As long as I get the area of one triangle, the other triangle has the same. So here they're asking what's the area of the triangle on the right? Well, I'm gonna solve for the triangle on the left. If I get the area of the triangle on the left, then I know the area of the triangle on the right. Now, I see this 12 and this 14 make a 90-degree angle here. And I remembered for triangles, the area of a triangle, I had to multiply these two numbers. So 12 times 14. I know 12 times 14 will give me the area of a rectangle, but this is a triangle. So I'm going to divide my answer. I'm going to divide this by 2 because a triangle is half of a rectangle. Now I type it on my calculator. 12 times 14, all of it divided by 2 gives me 84. So this triangle is 84. The question now is, how big is this triangle? What's the area of this triangle? And I'm going to say 84 as well. Because Cavalier's principle said, as long as the two shapes are similar, they have the same shape, the same idea, in this case, two triangles, they have the same base, they have the same height. One of them can be stacked straight, the other one could be stacked crooked. As long as that happens, as long as they have the same base, same stacking, same height, the area of one is the area of the other, or also the volume of one is equal to the volume of the other. So let's take a look at question number 18 here. The two quadrilaterals are drawn to scale. With Cavalier's principle in mind, find the area of the parallelogram to the right. Well, how many squares do we have on my rectangle here at the bottom? I have 1, 2, 3, 4 squares. And here I have 1, 2, 3, 4 squares. They're telling me that this is 3 and this whole thing is 3. I'm not saying 3 squares. You might be like, wait a minute, it's 4 squares and they're saying it's 3? Well, 3 feet. What if my squares are not 1 foot exactly? It's like a little less than 1 foot. And then I see this whole distance right here, this 4, this height, which is the same height as this one, right? I don't need to count those squares. I can tell they're the same. My rectangle here, it makes a 90-degree angle here. So I'm gonna get the area of my rectangle on the left side. I know for this rectangle, I have to go 3 times 4. So 3 times 4 gives me 12. I know for rectangle, I have to multiply the two sides that make the 90-degree angle. So 3 times 4 is 12. I don't divide it by two this time because this time I'm doing a rectangle. So just 3 times 4 is 12. So the area of the rectangle on the left is 12. The area of the parallelogram, this one, will also be 12. Very important Cavalieri principle. Okay, let's take a look at question number 19. Use Cavalieri's principle to determine whether the stacks of pennies on the left has the same volume as the stack of pennies on the right. So I see their pennies, right? I even see them, they're all the same color. So I see their pennies. One of them is stacked the same way, the other one not quite. But I'm gonna say the area of one penny, right, is the same thing as the other. So I just need to see whether they have the same amount of pennies. So I count on the left side. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there's 12 pennies on the left side. Let me count them on the right. I know they're a little sideways, so there's one, then this is two, three, four, five, six, seven. This is eight, nine. This is 10. This is 11, and this is 12. Well, they have the same amount of pennies, right? One of them is stacked straight, the other one is stacked sideways or a little crooked. But according to Cavalieri, remember it says as long as they have the same height, the bases are the same, the shape is the same. One of it could be straight, the other one could be crooked. They do have the same volume. So my answer in this case will be yes. Here they were not asking me what's the volume. They were just asking determine whether the stacks of pennies to the on the left has the same volume as the stack of pennies on the right. It was like a yes or no question. So yeah, I'm gonna say yes. Now let's take a look at number 20. Use Cavalier's principle to determine whether the stacks of pennies on the left has the same volume as the stack of coins on the right. Quarters are going to be yellow, dimes are going to be red, and pennies are going to be blue. Well, to be honest, in this case, I don't really need to count how many coins there are in each stack. I see the coins are different. On the left side, they're nothing but pennies because they're all blue, right? They're all pennies. On the right side, I see some quarters. I see what, four quarters because quarters are yellow. Dimes are red, so I see one dime. And then I see some pennies as well. Coins are different. The coins on the left, or my stack on the left, are not the same as the coins on the right. So Cavalieri principle said the coins have to be the same thing, right? The shape has to be same. Cavalieri only talks about the shape being straight, being stacked in order, like being straight, or crooked. However, it has to be the same all the way. So this one I'm gonna say no, because they're not the same coins.